Good morning. So today we're going to be examining the impact of influenza in the U.S., particularly the disproportionate effect that influenza has on vulnerable populations. For the purpose of this analysis, we're going to be defining vulnerable populations by age groups, um, because that is the data that was available to us. The ultimate goal here is to determine how to allocate supplemental medical staff to clinics and hospitals nationwide to better prepare for peak flu season. Today we're going to aim to answer three questions with this analysis. Number one, who is most susceptible to death by influenza? Number two, where are these individuals located? And number three, when does influenza begin to ramp up in the U.S.? We'll look at some peaks and see when we have the most influenza deaths, things like that. The answer to these questions are going to help us determine how we should allocate staff to states with the highest populations of vulnerable individuals. The graph we see over here on the right, while Spartan in nature, it just kind of gives us an idea of how many deaths we're talking about each year. And as we can see on the top of each of these bars, we're talking in the 400,000s, upper 300,000. So it's a lot of deaths, and anything we can do to mitigate those numbers, we should do, right? So let's dive into it. Here, what we're looking at is a pie chart for each state representing the flu deaths from each age group. Now, what we can see here, the brick red slices of the pie chart, those are representing our 65 and older deaths. And as we can see for each one of these pie charts, the 65 and older demographic is going to take the lion's share of deaths for any state. The time frame that these pie charts are drawing from is from 2009 to 2017. So we've got a pretty big sample size to look at. Conversely, grouping all other age groups under 65, they're taking up a very small percentage of these total deaths. We don't see any state where the 65 and under deaths come even close to the 65 and older deaths. Therefore, it's kind of easy to identify that these are going to be our most vulnerable populations, these 65 years and older age group. So what we should do is start looking at states that have higher populations of these vulnerable individuals. So we're kind of zeroing in on specifically the more elderly population here. One quick note, if a state reported less than 10 deaths for any particular month, the death count was recorded as suppressed in order to protect the identity of those that are affected. Therefore, there are two states, Alaska and District of Columbia, that have been omitted from this graph because they didn't provide enough usable data for this analysis. So now that we've kind of identified that we're looking at individuals that are 65 years and older, let's start looking at states that have more vulnerable populations. So what we're looking at here in this graph are two different measures. One, we're looking at the average mortality rate for a state, as well as just the pure 65 plus population of the state. So for average mortality, the states that are going to be highest in that are going to be the ones that are the darker shaded orange colors. So Pennsylvania, New York, Massachusetts, Missouri, Tennessee, those are going to be the ones that have the highest mortality rate. Mortality rate being defined as the percentage of specifically 65 plus individuals that have died from influenza. The blue circles represent the total population for 65 and over individuals in that state. So Florida, California, Texas, New York, those are going to be the ones that have the highest populations of 65 plus individuals. Now, just looking at this map, we can kind of get an idea of where the more problematic states lie. But to zero in on that a little bit more, looking at two charts here, on the top we've got the mortality rate kind of reimagined a little bit, so that we can look at these states ranked a little bit easier. And here, just like I mentioned a second ago, the states with the highest average mortality rate are going to be, New York, Tennessee, Hawaii, Massachusetts. However, when we look down here at the bottom, we see a little bit different picture, where states are categorized based on their population of 65 and older individuals. Here, again, like I mentioned before, California, Florida, Texas, New York, Pennsylvania, Illinois, Ohio. Those are going to be the states with the highest populations of elder individuals. Now, it brings up a question of, we're looking at two different metrics here, and we're trying to figure out where we should send medical staffing. And based on these two metrics, it creates kind of a different picture of which states need the most assistance. So, in order to take kind of a better look about which one of these metrics might be more valuable, we're going to look at this map. Excuse me. We're going to look at this line chart here that shows the number of deaths in each month for each state. Now, it's a little bit overwhelming. Because there's a lot of lines, 50 states, there's going to be a lot of data on this graph. But what we're kind of looking at here is the trends of, when do flu deaths peak? And that's what this chart is measuring, is just total number of flu deaths per month, per year for each state. And to kind of, before we get into the timeline of this, I want to take one look real quick at the difference between a state that has a high population of 65 and older individuals versus a state that has a high mortality rate of 65 and older individuals, just so we can get an idea for which of those metrics, mortality rate versus total population, are going to be more useful for our analysis and for our decision-making process. So let's look at two of the states. California had the highest population of 65 and older individuals. And let's look at Hawaii. Hawaii was in the top 4 for mortality rate. So looking at Hawaii's total death numbers, even though their mortality rate was high, their total death numbers weren't. They're really low numbers compared to California. So for that reason, total population of 65 and older individuals is going to be a much more useful metric in terms of determining where staffing should be allocated. Now, with that in mind, now that we've kind of answered this question of which metric is the most valuable, let's look at when flu season peaks. And as we can see here, you're going to have, first, let me talk about this graph. So I kind of rearranged the dates here to run from July to June, just so that we can kind of isolate what typically is the more deadly months, we can say that, months that typically have the highest flu deaths, which in this case is going to be December and January, right? As you can imagine, during the winter seasons, when you're going to start seeing the flu pop up more. And that's abundantly clear when we look at where the maximum number of deaths occur in each calendar year. So there's going to be a couple of years where, in 2009, December had the highest number. 2010, we kind of saw it peak a little bit in March. But if we were to look at most years, January is going to be when you have the most number of flu deaths. In 2013, it was really clearly January. 2015, clearly January. 2014, clearly January. 2017. There's a couple years where you kind of resurgence in March of the flu. But by and large, January is going to be the most problematic month. And for that reason, that's kind of when we should be staffing these hospitals and clinics, possibly even December, so that we can have assistance in place for when flu deaths begin to peak in January. So finally, we come to the ultimate question: is how should staffing be allocated? This is the question that we've been trying to answer through this whole thing. And now that we've identified the who, the where, and the when, what makes the most sense, in my opinion, is When we look at the state share of total flu deaths from 2009 to 2017, California had 13% of the total flu deaths in that time frame. New York had 9.84%. So what we can look at with this chart is we can see how many deaths that each state, the percentage of deaths each state was responsible for, and taking our pool of physicians and nurse assistants, physician assistants, etc. What we can do is we can use these percentages to allocate our staff. So 13% of our staff, for example, could be allocated to California. 9.84% could be allocated to New York. So on and so forth on down the line. And this can be, we can look, using these numbers, we can look at, the top 10 states. We can look at the top 25 states, by just kind of rearranging our metrics and what we're looking at with this graph. But this would be a useful graph to help us more effectively allocate staffing to the states that really need it. So those are my recommendations. If there are any questions, feel free to ask. But thank you for your time.